Hi, I'm Dion from leadingcertmathsvideos.com. Now, this first question here is actually relatively straightforward. Most of this differentiation question is, apart from maybe the last part. So we're asked to differentiate cos squared x with respect to x. So that implies dy dx. Remember, it's cos squared x. I'll just rewrite this as equal to cos x. And that's what cos squared x actually is. It's cos x all 3 squared. So we'll just that way to make it appear easier for this question. So dy dx is equal to 2 times cos x all to the power of 1. Now remember the chain rule. I'm going to use the chain rule in the next part of the question. I don't really want to do it twice to save time. Times the derivative of what's in the brackets. The derivative of cos x is minus sin x. That's times minus sin x. So that implies dy dx is equal to minus 2 sin x cos x. That part's actually reasonably straightforward. Now on to the next part of the question here. We have y equal to e to the power of minus x squared. Now it's asking you to find dy dx first of all. Now I can tell straight away that dy dx of that is equal to negative 2x e to the negative x squared. Because basically what you do here is, what I've done before, is the derivative of that times the derivative of a u term, which is minus x squared. So the derivative of this term here is e to the minus x all to be squared, times the derivative of e to the x squared, minus x to the squared, sorry. So that's obviously negative 2x. But I'll just show you that using the chain rule. Now using the chain rule, we will let u equal negative x squared. That implies that u dx is equal to 2x. So that implies y is equal to e to the power of u. And dy du is equal to e to the power of u, as we all know. And then du dx is equal to 2x. Now don't forget here we have to find dy dx. So dy dx is equal to dy du times du dx. So that is, sorry, that should be negative 2. So basically that's what we have to do here. So dy du is equal to e to u, and then times du dx is equal to negative 2x. We'll just put that at the start. Negative 2 equal to negative 2x. That's equal to negative 2 e to u. And don't forget our e was negative x squared. So we'll just replace that. Negative x squared. And that's your dy dx there. It's equal to, so basically at the start we're just given this. And then when we have to differentiate it, we just have to basically get this term here and multiply by the derivative of the u term here, which is negative 2x. So that's what worked out there. It's actually fairly straightforward, but I just want to show you the chain rule there. And our next part of the question is find the coordinates of the turning point of the curve. So there's only one point. Now we know that when there's a turning point, the slope is equal to 0, and dy dx is equal to the slope. That's what we're all finding when we get the derivative of something. We're finding the slope. So the slope of this line is equal to negative 2x times e to x, minus x squared. Now the slope of that line is the turning point of the slope is always going to be equal to 0. So just to say we have a turning point here. Now, like that's only just one example. Now the slope of this line here is going to be negative. The slope of the tangent here is going to be positive. But on a turning point, the slope is always going to be 0. So when the y dx squared, like when it was here, it would be negative. But here it's always going to be 0. So that means that this term here equals 0. So we know that e to the x, we know that this can never be 0 because any real number to the power of another number can actually never be 0. Even e to the 0 itself will be 1. So that means that 2x is equal to 0. And that kind of goes along because it's turning point, not points. So we know that this term on the right hand equals 0. So that implies that negative 2x is equal to 0. And that basically says implies that x is equal to 0. And the coordinates of the turning point. Now add x equal to 0. X equal to 0. Now our original equation was x to minus x squared, or e to minus x squared. So e to the power of 0. So when x is equal to 0, e to the power of 0 is equal to 1. So your coordinates of the turning point are your x coordinate is equal to 0 and your y coordinate is equal to 1. So that's the coordinates of your turning point right there. Now we're asked to say determine whether a turning point is a local minimum or a local maximum. So basically to find out whether it's a local minimum or local maximum, we have to find dy dx squared. So if our equation now dy dx was negative 2 times e to the minus 2x. Right. dy dx is equal to negative 2x, times e to the minus x squared. Now we have to get the derivative of this to find the nature of the turning point. So here we have two terms. The easiest way to do this is use your u and your v. You should all remember that. So we let 2x equal to u, and we let e equal to v. So the derivative of that is equal to u times dv dx. So it's negative 2x times dv dx. The derivative of this is actually negative 2x times e to the negative x squared plus v times u dx. So I'll just write down d2y dx squared is equal to this plus v times the u dx, which is v, which is our term here, times the u dx is equal to negative 2. So I'll just write down the negative 2 first. And v is equal to e to the minus x squared. Now the nature of this turning point at the point 0, 1. Now there's no need really to expand this any further. We're looking for the nature of the turning point at this point 0, 1. So at x equal to 0. But we know this is 0 then. So we can just blank all of that. And we have minus 2 times e to 0. Now any number to the power of 0 is 1. So there we go. So our d2 dx squared at this point at x equal to 0 equals minus 2. So it's a negative number, so that means that our curve is a maximum turning point. So that implies the maximum. Alright, if you found this video useful, please add me on Facebook, Twitter, or on YouTube. Alright, thanks very much.